Hope everybody had a good weekend. We're ready to kick off week 6 of virtual learning. It's supposed to be really warm today. Yeah, that's what I was just looking at, actually. Like, I thought it was supposed to be nice, but I looked and it's supposed to be in like 70s. Like, it's probably warm by now, right? I don't know, at least later I know it's supposed to be in the 70s. So that's awesome. I can't wait for this class to get done. I'm going to peace out. Finish up some work. I'm going to go outside. Ted's out on his deck tanning right now. So, yeah, this is awesome. Hopefully this is actually the beginning of like consistent warm weather. Maybe. I don't know, it's still kind of cool in the morning. I think like this morning it was still decently cold, like 50 or so. It's been kind of rainy, but that's fine. So hopefully at least in the afternoons we can get consistent warm weather. Maybe it will kill the COVID. I wouldn't count on it, but maybe. Heat wave. We'll see. All right, so going back to our sequences and series. So we talked last time about arithmetic. So let's see this sequence. Let's see if it is arithmetic. So we have fractions here. If you need to think about those, that's 2, 2.5, 3, 3.5, etc. So I should be able to identify that, yes, this is an arithmetic sequence because the same amount is being added each time. Right? The difference is 1/2 or 0.5. Right? 2 to 2.5 to 3 to 3.5, etc. All right, so number 1, what is the explicit form? So we had a formula for that, which is a1 plus n minus 1 times d. All right, this is how we create the explicit form of an arithmetic sequence specifically. Okay, not any sequence, just an arithmetic sequence. So a1, the first term is 2 plus n minus 1 times 1/2. I'll go ahead and simplify this. So 2 plus 1/2 n minus 1/2. Right, if you just distribute that 1/2 to both of those. 2 minus 1/2 is 1.5, which is 3/2. So 3/2 plus 1/2 n. Or if you really wanted to get fancy, if you wanted to factor out the 1/2, right, you could also go with this, 3 plus n times 1/2. It looks a little cleaner since there's only the one fraction instead of the two. Don't know. But either way, it works. And then number 2 asks us, what is the 8th partial sum? All right, so since it's arithmetic, we have a formula for arithmetic partial sums, which is, n divided by 2 is a1 plus an. So the 8th one, so 8 over 2, so 8 divided by 2 is 4. a1, the first term is 2, plus a8. Now at the moment I don't know what a8 is, but I have a formula for it. I could use my explicit form, so off to the side here, a8, 1/2, 3 plus 8. 3 plus 8 is 11, so 11/3. Two plus 11/3. 2 I can think of as 6/3. So 6/3 plus 11/3 is 17/3. 4 times 17, 4 times 10 is 40, 4 times 7, 28, so 68/3. Wait, why did I do thirds? You guys, what? That's not the form. Okay. This should not be 1/3. This should be 1/2. So 11/2. Two plus 11/2. So 2 is 4/2. 4/2 plus 11/2. 15/2. 15 times 4 is 60. 60/2 is 30. It's been a rough day. Inset, well, I don't want to tell that story again, but it's been a rough day. Okay, so this is my partial sum formula for arithmetic. This is my arithmetic explicit form. Okay, so again, what is the difference between a sequence and a sum? A sum is just a sequence that you add up the terms. Right? And so we could say like the 8th partial sum. So I regret doing the whole problem in pen. I regret doing the problem in general. I regret clicking start. Okay, so let's take a look at our next type of sequence. We'll probably do 2 days for this whole lesson. It's kind of a lot of stuff, so I don't want to pack it into one day. I don't know, we'll see. Geometric sequence. So this is also something that you did in geometry and or algebra 1b. So a sequence when the ratios of each consecutive terms are the same. Okay, ratios is underlined because we call the ratio R. All right, first example, 2, 4, 8, 16. All right, so hopefully we can see that these are all times 2. So this is a geometric sequence where the ratio is 2 because that's the thing that's being multiplied each time. Right? If you're now these are kind of obvious to see, but if you're ever in doubt about what the ratio is, then we can just kind of work backwards and divide. So like 4 divided by 2 is 2. 8 divided by 4 is 2. 16 divided by 8 is 2. So I can see that ratio when I divide is all the same. So that's what's being multiplied each time is 2. Okay. Similar thing here. So 12 times 36 is, or sorry, 12 times 3 would make 36. So I think that's the ratio. But if I'm not sure, like between 36 and 108, well, we can just work back, divide. 108 divided by 36 is 3. 324 divided by 108 is 3. So yeah, this is also times 3, or this is also times 3. So this is also a geometric sequence, but the ratio is 3. The ratio could be anything. It could be a whole number, it could be a decimal, it could be a fraction. The ratio could be positive, the ratio could be negative. It doesn't matter. But it just represents what are we multiplying each time. I think he snapped. I did this morning. I'll go ahead and say, so in my calculus stream this morning, I taught for an hour, right? Like calculus classes are always pretty long because it's a hard class, there's lots of stuff to do. So I taught it for an hour straight, right? Of going through these like AP test questions. And then once I got done, I was like, all right, and I asked some question and I got no response. I was like no one put anything in the chat or anything, and I was like, okay, what's like usually it's an okay talkative class. Like it depends on the day. Sometimes they're more quiet, but usually it's pretty talkative with just random stuff. And so yeah, so then I pulled up like my streaming screen. I'd never clicked start streaming. Nothing. I didn't hit record. I didn't hit start screaming. Start screaming. I started screaming. I didn't hit start streaming, so that was just completely lost, completely useless. I literally sat in a room and talked to myself for over an hour for nothing. Absolutely nothing. It was rough. It was a rough time. I just went and just like laid on my bed for a second. I was just like, okay. I considered, just handing in my resignation and just saying, hey, I gave this teaching thing a good run. It was fun for a minute, and then oh man. I got timed out by my own chat bot because I was screaming all caps in the chat. I would have thrown a temper tantrum. I pretty much did. I just sat here like this for quite a while. Ugh. It was painful. Twitch life is hard, man. This is that streamer life. It's hard. But I don't know. And then I've been doing a few other I've made a bunch of dumb mistakes in my other classes as well. Like doing the whole problem with the 3 instead of a 2 there or something. So I don't know. I'm just not on today. I don't know what's going on. It really started off the week great. Okay. Sounds like you need sleep. I don't think... I mean, I slept a lot last night. More than I usually do. I don't know. I do not know. All right. The explicit formula for the nth term of a geometric sequence is this. Okay, so for arithmetic... That does not say arithmetic. And for arithmetic, we know it's this thing. So this is the one now for geometric. So we have 2 separate ones. So it's hard. So we just got to make sure we're keeping track of which one is which. All right. A1 still represents the first term. And R is the common ratio of the consecutive terms. So what's being multiplied each time. All right. So 630, 150, 750, find A7. All right. So from one to the next, 30. 150 divided by 30 is 5, so that's also times 5. 750 divided by 150 is 5, so that's also times 5. Now do be careful, because sometimes you'll encounter sequences that appear to be geometric or appear to be arithmetic but aren't actually. So maybe you get something like this, where if you look at these, you're like, oh, times 5. And then you look at these and you're like, oh, times 5. And so you're like, oh, this must be geometric. It's just times 5 for everything. But if I look at these two, 150 times 5 is not 650. Okay, so this would not be a geometric sequence, nor is it arithmetic. All right, so do make sure that you check to make sure that the entire sequence is following the pattern, not just one piece. Okay, find A7. Well, let's just find the explicit form first. So for a geometric sequence, it's A1, but we know A1 is 6. The first term is 6. Times the ratio is 5 to the power of n minus 1. So therefore, A7 to the power of 7 minus 1 is 6. So this is going to be a really large number. All right. 937,000. No, wait. 93,750. So first we use the explicit form, or found the explicit form. Once we had it, then we could plug in 6, or plug in 7, because we want to know the 7th term. Right, so this is not a sum, this is the 7th term. If I kept, so 1, 2, 3, 4, 5, 6, 7 would be 93,750. And then it would continue on. We also have a partial sum formula for a geometric series. Okay, now again, we already have a partial sum formula for arithmetic. This is our partial sum formula if we're talking about an arithmetic sequence. So let's talk about a geometric sequence. So it's a little more complicated. A1, 1 minus r to the nth power divided by 1 minus r. Okay, there's certainly a lot more going on. Okay, so find the 5th partial sum. Okay, so that means S5. So first of all, I need to check to make sure that this is actually a geometric sequence. So I'll divide. Negative 9 divided by 27, negative 1/3, 3 divided by negative 9, also negative 1/3. So I can see that the ratio is the same. The ratio is negative 1/3. All right, but I have to check to make sure, because otherwise I can only use the formula if this is geometric. So I have to be sure it's geometric. Okay. So I know what A1 is. I know what the ratio is. So we should be able to just use our formula now. So S5 equals A1. 1 minus negative 1/3, so 1 plus 1/3. 2, well, actually, hold on. That's because I need to the nth. So 1 minus negative 1/3 to the nth power, so to the 5th power, divided by 1 minus negative 1/3. So that one would be 1 plus 1/3. Okay, this does not turn into a plus yet right here because first we have to do the exponent before we try to combine whatever these signs are. Okay, but on the bottom there's no exponent on here, it's just 1 minus negative 1/3, so we can go ahead and change that to 1 plus 1/3. All right, so a bit more fraction work. So negative 1/3 to the 5th power. Let's see, what's 3 to the 5th? 243, okay. Okay, so I did this because 3 to the 5th is 243. So we can just do the numerator to the 5th power, denominator to the 5th power. So 1 to the 5th is still just 1. 3 to the 5th is 243. And the negative, since it's an odd exponent, the negative will stay. So minus negative turns into positive. One plus 243. So I want to think of this one as 243 over 243 so that it has a common denominator. So 243 plus 1 is 244. Similar for the denominator, I want to think of this 1 as 3 over 3. So 3 plus 1 is 4. 4/3. I have a complex fraction here, right? A fraction divided by another fraction. So let's not do fraction within a fraction. Let's instead multiply by the reciprocal. So instead of divided by 4/3, we'll multiply by 3/4. Three and 243, so that would leave me with 81 right there in the denominator. That 3 just becomes a 1, so 1/4. (27) and 81, those can simplify because 27 is 3 cubed. 81 is 3 to the 4th. All right, so if I divided those, I would just be left with 1/3. Times 1/4. (244) and 4 should be divisible. 244 should be divisible by 4, and it is. So 61. So this becomes 61/3. And 61/3 is not divisible. So this is our final answer. This is the, what did we say it was? The 5th? Yes, this is the 5th partial sum. So if I add up the first 5 terms of this equation, we get 61/3. These problems on the PFA are like enter your answer. So you would have to actually type in, like what you would type in is 61/3. All right, no spaces, just 61/3 to represent 61/3. And yes, your answer has to be fully simplified. Otherwise, it will be marked incorrect by Summit. If you get a negative value, just put that in front. So it's just using the formula. There's just more to do. Is this PFA hard? As long as you keep track of which formula is which, then no, I don't think so. Maybe some of the fraction stuff is annoying, but because we just have, well, I guess it's kind of hard with our next one too. We have like 5 formulas, but so far we have 4 formulas that we need to know, right? We have this formula for geometric partial sum, this formula for geometric sequence, this formula for arithmetic sequence, this formula for arithmetic partial sum. Okay, so it's just that there's a lot of things to remember. I don't think that any of them are individually that hard, but maybe just kind of keeping track of them all together could be. Plus, we still have other things that we're going to learn for other objectives as well. It's a little bit, it's tough. I won't say it's easy. But as long as you can keep track which formulas go with what, then I think you'll be okay. We could go to infinite series, but I don't really want to do that yet. Let's do another example of geometric partial sum. Let me just add in one here. Actually, what was one of our ones from earlier? $630, $150, $750. Okay. And let's say we want to find the 7th partial sum. All right, so that would be S7. Well, we already know a couple things. We already know the starting amount is 6. We know the ratio is 5 because it takes multiplying by 5 to get to each next term. Okay, so let's use our formula. So A1, 1 minus the ratio to the nth, so 5 to the 7th, divided by 1 minus the ratio. So just plugging everything in. Right. A1, A1. S7, S7, and then the ratio is the ratio. Every time you say A1, I picture my mom saying A1A Beachfront Avenue. What is that, though? What's A1A Beachfront Avenue? I don't think so. But then again, my brain also doesn't work today, so maybe I'm just being oblivious. I don't know, what is it? Explain. 5 to the 7th is 78,125. 1 minus 5, negative 4. 1 minus 78,125. It's ice, ice, baby. Okay, Boomer. And now just simplifying the fraction. We can definitely do right. 6 and 4 would simplify into 3 and negative 2. So 7, 8, 1, 2, 4, and 2 are both divisible by 2. So that would be 39062. No, I called you a boomer. Times negative 3. Oh, oops. Sorry. Hold on, I forgot. Up here, 1 minus, so this would be negative. So this would be negative. Negative, so the negative times the negative would make a positive. So we would get positive 117,186. All right, dude. Hey, don't get all offensive. I'm just saying, like, or defensive. I'm just